Section 2 of the Cprimer deals with basic C syntax. We're only going to emphasize a couple of important points. First, integers rule. Because the kernel needs to be absolutely reliable, no floats or doubles appear in the millions of lines of kernel code. In turn, the arguments and return values of all system calls are integers of various types. The integer types in C merely specifies the size of a memory cell. Only their relative sizes are mandated. A char is 1 byte. A short is 2 bytes. An int is going to be 4 bytes, and a long 8 bytes. And on unusual machines, these are what their sizes are. While a char variable is the name of 1 byte, the other integer types can have different values on different devices. You can also put the word unsigned in front of these types to indicate that they should be unsigned, be interpreted as positive numbers rather than positive and negative numbers. We'll also need bitwise operators. Study the exercise on page 13 carefully. Eventually, you'll turn in the completed page 13. This completing that exercise requires understanding how 2's complement numbers work. Okay, assuming that the following are char integers, that's 8 bits. Let's look at some of these bitwise operators. Tilde 3 is the complement of 3. If to understand how this works, we have to write the number 3 out in binary. We have 8 bits, so you can see that only the far left, the ones place for a 1 and the 2's place for a 2, so this is 3. And the complement of this means replace all the zeros with 1s, all the 1s with 0s, so here's the complement. Now because the sign bit here is set to 1, this is a negative number, and if we had all 1s here, it would equals -1, so we're taking away 3 here from -1, so we end up with -4. Okay, let's look at another one. This is 6 ampersand 3. This is the bitwise AND operator. So we look at 6. Here's the zeros, the 1's place, the 2's and the 4's. This is 6. This is again 3 as above. When we bitwise AND, we look in the corresponding places. 0 plus 1 is 0. 1 and 1 is 1. 1 and 0 is 0. And all the rest are 0 and 0, 0. So we end up with 2 being the bitwise AND of 6 and 3. It's only the corresponding entries that match up that you get 1s. The vertical bar is bitwise OR. It means if you, in any given place, if one or the other is 1, then it's 1 or both. So here you can see that we have a 1 in the first place because we've got a 1 there. 2 1s give us 1 there and 1 over here and 1. So we get all 3 bits set here to 1 in the far right. And this is the number 7. 1 plus 2 plus 4. 4 plus 2 is 6. 6 plus 1 is 7. Okay, we have shift operators. 16 shift to the right 1 place means here's 16. There's the 1's place, 2's place, 4's place, 8's place. Well, actually, it should have been 1 over here. 16 place, and this is 4, so this is miswritten, but this should be, let's redo this.